Okay, how are we going to calculate the hydrogen ion in a solution? So let's say we have, this would be our given information here. Let's say we have hydroxide ion concentration at 0.01 molar. Well, all we have to do is take our equation, hydrogen ion times hydroxide ion is equal to 1 times 10 to the negative 14. I plug in my value that's given for the hydroxide ion, and from there, I just do a little bit of algebra and I can find the hydrogen ion concentration. And so what I see is that the hydroxide ion is greater than the hydrogen ion, therefore it's a basic solution. So now, how can I go further with this? Well, once I know the hydrogen ion concentration, as I have determined from above, which was 1 times 10 to the negative 12, then I can plug into this equation here. pH is equal to the negative log of the hydrogen ion concentration. So I plug in my value for the hydrogen ion concentration and I find out that my pH is 12. This is the pH scale. Anything on the pH scale from 0 to 7 is acidic, 7 is your neutral point, and anything from 7 to 14 is basic. And this is a handy equation to know that pH plus POH is always 14. So now we'll look at how to calculate POH. So if I'm given a hydroxide solution such as this, and I want to find from that hydroxide ion, that base solution, I want to find what my pH of the solution is. Well, first of all, I have to look at what the base is. And so if it's a 0.0011 molar concentration of the CaOH2, then this is how that base ionizes. And it's a strong base. We haven't talked about any of the weak ones yet. Single arrow indicates it's a strong base, just like the acids. And so what I know then is that the concentration of this ion has to be twice the concentration of the solution. So I know that my hydroxide ion concentration is a 0.0022. So now I can say, just like the pH equation, I have a POH equation, which is equal to the negative log of the hydroxide ion concentration. So then I plug in, use my calculator, take the negative log of that value, which is the concentration of the hydroxide ion. If it only had a 1-to-1 ratio for Na to OH, then you would just take your OH concentration to be exactly the same. So let's say this were a 0.0011 of NaOH. This would also be a 0.0011. This one I did, intentionally so that you would know to be careful to look at mole ratios. Anyway, so I figure out, I go back down here, I do my little bit of math, plug into my calculator, I get a POH of 2.6. Once I know what my POH is, I plug into that formula that I showed you on the last page, plus pH is equal to 14, and then I can calculate what my pH is.